Bartels and Matthew Bellers, and to my right is Mohammed Qadri and Logan Spence. We will be presenting our charging station design prototype. Starting with the needs statement. Due to Freddie's power requirements, he is required to be frequently monitored and charged, which is an inconvenience for the user. It would be problematic for Freddie to lose power during a session with the user. Our team's goal is to design a prototype that will be safe, cost-effective, and satisfy Freddie's 3" by 3" docking accuracy.
Okay, so some of the objectives and constraints we came up with were that the size be less than 8 cubic feet absolute maximum. The weight constraint is also an absolute maximum of 20 pounds. The design needed to be stable, so there's no risk of it tipping over when Freddie was trying to achieve docking. It should be portable so that it can be brought from room to room or to friend or family's house. The absolute maximum cost for manufacture would be $250. Can be no, absolutely zero chance of injury, and we want to achieve the docking criteria set out of 3" by 3", and we're hoping for, on a 20 trial run, to have him successfully dock at least 85% of the time.
So after all our objectives were met, we came up with 3 conceptual designs. The first one on the far left, we called the depressed hemisphere. In this one, the terminals were unexposed, which made it really safe. The robot will drive forward onto the ramp until the ball went into the depressed hemisphere and charge would be initiated. In the middle, the flying V, we called it. It had a V-shaped fork that was located on a swivel to improve the docking accuracy and increase the range of entrance of Freddie. On the far right, our simple design. Freddie will drive straight forward onto the ramp. The terminals are exposed, but they are still safe, and we'll get into that later in the presentation. And there will be terminals on the bottom of Freddie's foot, which will make contact with the spring-loaded terminals on the charger, initiating contact. We chose through the criteria based decision-making tables and weighted values, and our overall group's consensus, we chose the simple design. Final design. As you can see in the animation on the right-hand side, Freddie's foot will approach straight on. He will enter the ramp with the aid of the tapered forks that are at 15 degrees. These fairings will aid with the angle of approach. The charging terminal is located on the bottom of Freddie's foot, which you can see in the bottom picture. We'll make contact with the 2 terminals on the charger, and the charging will commence. The spring-loaded terminals located on the Freddie charger will ensure an adequate connection is made.
Okay, so this is the picture of our final prototype, which was 3D printed from biodegradable PLA plastic. You can see the flat base, which was, although we didn't have a chance to test it on carpet, was designed to maintain a constant height between the ball and the foot of the charging terminals. It was tested on vinyl floor with a bit of a lip, and Freddie has no problem popping up onto the surface, so that worked out well. There's stainless steel charging terminals, which are spring-loaded to allow for any angle of Freddie's foot or any inconsistencies. We have an LED light hidden inside the Freddie's head-themed dome on the top, and we went with a design that used no moving parts except for the spring action of the terminals to ensure that it was always going to be reliable and the product would never break down. We also tried to choose an aesthetically pleasing design because we figured it was a product for kids, so it would be fun to get a little creative with the shape. This is the inside of our prototype. We weren't positive on what the charging requirements were going to be for the final product, so we just have a simple LED circuit hooked up inside. The yellow arrows pointing to our batteries that power the light. The green arrow is the underside of the plate holding the LED in position, and the blue arrow shows the epoxy that holds the wires and terminals in place. Our prototype's bottom cover is attached with magnets just to ensure that we'd be able to get back inside and make any changes if necessary. However, the final product would have the bottom cover epoxy because there would be no reason for customers to access the electronics inside. The idea was to have the inside hollowed out as well, so that if any electronics needed to be stored in the charger itself, there would be space for that. And we would, for the final design, propose a laptop-style charger, which has the transformer box included in the charge cable.
So after seeing the prototype and the exposed charging terminals, you may think that you would get shocked if you touched the two terminals. To ensure this would not be a risk, we looked at the national safety standards that are currently in practice. In this case, we looked specifically at the UL Safety Standard 1310. This covers a Class 2 charger for a child's toy. It specifies that the maximum allowable voltage for charging is to be less than 42 volts. So to help understand the safety of the charging, let's assume that it operates at 12 volts. The resistance of human skin varies from 1,000 to 100,000 ohms, 1,000 being wet or cut skin. If the average child's skin has a resistance of 20,000 ohms, using Ohm's law, we can determine that the current flowing through the child will be less than 1 milliamp. Looking at the table, you can see the effects of varying currents flowing through the human body. It can be seen that the current value of 1 milliamp would be a faint tingle if it is even noticed by the child at all. So this simple calculation demonstrates that the two exposed terminals will be safe for use in the household.
So once we developed our prototype, we proceeded to test, just to make sure we met our objectives. So for our size, as Matt mentioned, we wanted to be less than 8 cubic feet. We've achieved this with a total size of 0.032 cubic feet. For weight, we wanted less than 20 pounds. Currently, our weight sits at 1.1 roughly pounds. Keep in mind, this is just the prototype itself with no internal components, so the weight would increase by a bit. Stability. So as Freddie would dock, we wanted the charger to maintain stability both horizontally and vertically. It did that, so we gave it a pass on that. Portability, our charger is portable, so it passed on that as well. Construction cost, so we had a cost of less than or equal to $250. Incorporating material costs, labor costs, and potential electrical components priced out. For 100 units, each unit would cost about $76.79. For safety, as Dave mentioned, the exposed terminals don't pose a risk. In terms of anything else, we think that overall it would be safe. Docking accuracy, so we have a 3-inch by 3-inch. We have it listed as conditional up there because our charger meets the objective of a 3-inch depth, however only supports a 1.5 roughly inch width, which doesn't meet the objective of a 3-inch width. So we have some future recommendations that we'll talk about later on how to improve that. So at 85% docking accuracy on 20 tests, Freddie was able to successfully dock 90% of the time when the approach angle was less than 15 degrees. Design practicality, we passed on that part. We feel overall that our design is safe, it does the job, so we passed on that. Coming up here, we have a video that we put together that just takes us through the steps of our design, from 3D rendering on SolidWorks to 3D printing, and just some of the tests that we put together. for some future recommendations that we have if we're going to a production phase is to incorporate infrared guides in the dome. This is just to help Freddie determine where the charger actually is and also help for positioning accuracy. As the prototype sits, we don't have a current cutout for the AC adapter. We just have batteries in there, as Matt mentioned earlier, just to test the connection of Freddie and the charger itself. So if it were to go to production, we suggest cut out even muster on the back end there. We'd also like to widen the guide fairings to increase the approach angle. Currently we have a total angle of 30 degrees, so we'd just like to increase that angle a bit to also assist Freddie in docking. We'd also like to increase the angle of the back plate. By this, I don't know if you noticed in the video, but there was some times when he was docking and the light would flicker. This wasn't because there wasn't a secure connection, it was more so if the charging station itself was closer than expected, when Freddie would roll on, his wheels would keep spinning and it would kind of lift up his front wheel there. So currently our back plate sits at 90 degrees. We kind of like to taper it out from the bottom up to stop that front wheel from kicking out there. So in conclusion, our goal was to design a safe and reliable charging station that allows Freddie to recharge. From the 3 conceptual designs that Logan mentioned, the simple design implemented the most practical concept and methods for a charging station. It was proven that leaving the charging terminals exposed poses no threat to anyone using the charger. And the objectives were met to a satisfactory level, however, there is definitely room for improvement.
We'd like to give a special thanks to Dr. Livingston, Dr. Deschef, and RTA Bassam. We'd like to open the floor to questions.
Thank you.
Okay, thanks very much. So I do have a few questions. One of the things, just a smallish thing, when your criteria for sort of reliable docking, you mentioned 85%.
Yeah.
Why not 100%?
I would say we base that largely off the Roomba backing, which seems to be the current most popular product that is an autonomous charging device. And watching one of those try and charge, it often comes in and has to back up a little bit and try again. So we consider that as a fail. And it's using infrared and things like that. So we just kind of figured nothing is 100%. We didn't want to claim that it would charge on the first try, every try, and not have that happen.
It's just interesting to set that as maybe that is realistic. I thought that one's goal would almost always be close to perfection.
Under the
I'm going to argue with you about this concept of the exposed terminals. Whether or not it's safe or not, I think in some ways is irrelevant. But do you think a parent would be concerned about the exposed terminals? So if you sort of said, well, don't worry, it's just a small tingle, do you think they'd be, I think they're going to be convinced by that?
We did consider that, and then it wasn't mentioned in one of our recommendations, but we would like to design some sort of limit switch or some sort of little button that when the foot is over top of the chargers, it does trigger the charging.
Right.
And then that it is, we kind of just felt like this was safe, and then we haven't furthered it.
Right.
We would like to do that.
I mean, I think perceptions are as almost as important as reality. But, you know, so I appreciate the fact that you actually researched that and looked into that. But parents would be incredibly protected, as they should be.
I'd like to add to a slight tingle would be like the absolute worst world.
Yeah, but a slight tingle with someone, it doesn't, anyway.
I wouldn't say that, I don't think it would be realistic for a slight tingle to occur, but that's something we would like to, if this design went forward, covers would be smart, obviously, and it would be interesting to discuss it with some electronics guys, because that's a field that's kind of a little bit beyond us.
And the other question, and I might have missed this, did you say that you didn't test this on car?
We did not.
Okay, and that was because?
We didn't want to take Freddie too far away from the design room. We weren't sure. Yeah, when we would find carpet that, like, there's carpet on these steps, but it's very smooth, flat carpet, and
bottom, it's a shag carpet or something. The other groups, they were saying because the height differences with the weights. Ours has the bottom runway, so once it gets on top of that, it would get a good charge point as well.
By the way, I do appreciate, I don't want to sound negative with this question, I really appreciate your attempt, successful attempt to you know, to make that, you know, aesthetically pleasing and to, you know, to tie in with the theme, make it sort of spacey, and that's great. So, thanks for doing that. Thank you.
Very well done execution. Just to reiterate Nigel's comment, that you really made it appealing to the children, because I'm sure for the marketing people, I know they always fight with the engineers, and the engineers are trying to make it as simple as possible. The marketers are trying to say, put this in there, so very well done in that aspect.
I have a few questions. Yeah, I agree 100%. Aesthetically, wow, you know, great, and again, nice small size. So I have a few questions. Okay, so again, initially 8 cubic feet. Pretty big. That's a hail. That was a
2 by 2 by 2.
hay bale.
Yeah.
Motivation, and for the original, eventually, just, you know, guide me through that. Why so big, and then, you know, 0.03 cubic feet?
Well, in terms of that, is that much like the other group mentioned before, we just thought Freddie would be a bit bigger. So we just kind of.
Oh, you thought you was like,
Yeah.
life size.
Oh.
Bigger.
All right.
It's like an Irish.
Okay, all right, fair enough.
Something else we did very early on, like before even our conceptual design is considered, was the possibility of having like a little Freddy garage that you could drive into. So that kind of 8 cubic feet, like 2 by 2 by 2, we were looking, if you did have a little box you could drive into, that would be the maximum.
Maybe when you talk about your objectives and your final report, explain the 8 cubic feet and then the 20 pounds. I believe you said 20 pounds somewhere.
Yeah.
Okay, let's talk about electrical safety very quickly. This is something that I know quite a bit about. 42 volts. I'm not sure what spec you looked at. Like that, from everything I know, is not right. So there's something wrong you found. Children's toys and most consumer products with exposed electrical leads is 12 volts. It just is. Once you get above 24 volts, it's a different classification of electrical safety, and I cannot possibly imagine why anyone would have allowed 42 volts. So just double check, but I can tell you right now, if you look at the CSA, it's less than 12 volts. As a matter of style, as Nigel picked up, yeah, you wouldn't want to say anybody's going to touch it potentially. That's just really nothing to do with anything. But again, what happens is when you get to 12 volts or less, it is difficult for that level of electrical potential to cross skin, unless somebody was to, as you're saying, lick it or something like that. But you've already addressed that. You said you might put a limit switch. So when we give you all this feedback in your final report, make an effort to address it. So that's basically why we're telling you. You still have one more chance to address this feedback in your and then my last question was, I noticed it was slipping on the floor when you guys were docking. So, and in one video you actually propped it up against the wall, which is clever, because then that would restrain it. So do you want to talk about, in your FDR, any other ways you could use to immobilize the station better? Do you have any suggestions right now?
We do have some rubber sticky pads on the bottom to resist sliding, and it is on a smooth surface, quite stable. We intended for the design to be placed close to a wall, so we figured no one's going to want this to be just in the middle of their floor anyway. Although we did find it kind of interesting. It seemed like as we got to more extreme angles, when Freddie was coming in, it being able to move a tiny bit, sort of assisted Freddie making it in. When it was up against the wall, you could hear the motor strain a little bit as he straightened out, but when it did shift a little bit, it kind of came together a little bit more easily. So maybe not moving would be a requirement, in which case we could probably increase the weight and increase the number of sticky pads. But if a little bit of movement wasn't an issue, we kind of think that it actually helps out a little bit.
So that I don't know. Eventually, Nigel would have some sort of a dead reckoning or feedback.
Yeah.
But I don't know if relative motion each time is helpful or not. Okay. All right, guys. Any other questions, by the way, from anyone? No? No one's smiling? Okay, great.